Hello everyone, today I'm going to teach you sequence encoding. So, why did I decide to make this tutorial? Well, a lot of people on the theoretically possible levels list don't really know how to make sequence encoders. So today I'm going to be going over all of the information and all of the basics you need to know for sequence encoding. Let's get started. What is a sequence and how does it work? Well, very simple definition. The sequence is an ordered collection of terms that looks something like this. Now, these, as you can see, these terms or numbers are separated by commas. And very important thing about these sequences is that they get translated into binary strings. I'm going to get over why in a later panel. But for now, all you need to know is that the zeros represent a term's value and the ones separate the terms. So something like this. So you see, when we don't have a 0 after a 1, it's considered a 0 term, so it's completely fine. Then last thing is that these sequences have to be finite in length. They can be infinite because TPLL doesn't allow infinite sequences and you can't really do anything with them at all in the first place. And the most common type of sequence we use in TPL are number sequences, which is basically like this, but I wrote an example here as well. Now, there are two things that build up a sequence: bits and terms. Bits are the ones and zeros in the binary string, and multiple of them make a term. Now, the terms are obviously an element in the sequence, and they will represent a number most of the time. That is because usually we use these number sequences because they appear everywhere. But in unique scenarios, there can be other types of sequence systems where these binary strings aren't representing numbers, rather symbols, characters, like closed and open brackets. Now, how do we make this in GD? How do we make sense of this? Well, we can do two things with a binary string, that is, writing and reading it. Let's go over writing first. Let's say we have this binary string. We can do two things, which is writing a 0 or 1 at the end of the string. To do this, we have to double the distance and add 1. What does this mean? Well, first we have to translate this binary string into a decimal number. If we would double that decimal number, an extra 0 will get added. Now, if we were to double the distance or the decimal number and add 1, we would add a 1 at the end of the sequence. That means basically applying a new term. For this, we need an exponent counter. Alright, so how do we make something that doubles the distance between these two blocks each click? It's very simple actually. To begin, we are going to apply group ID 1 to this collision block. It really depends on what group ID you want to apply, but I'm going to use 1 for this and 2 for this one. Now, let's place down a touch trigger, which can be found on the third page of the triggers. And this will activate group 3 because that's the next free group. So now, we are going to put down a move trigger, which is going to be spawn trigger, multi-trigger. The move time is going to be 0, so it instantly moves there. And this is going to target this block, which will jump to 1. So, we enable target mode, set this to X only, and then target group ID 1. Also, don't forget to apply 3 to this trigger. So now we have this. Alright, perfect. So, 1 needs to follow the distance 2 makes, like this collision block. This has to follow this collision block. We need a follow trigger for that. Spawn triggered, all that stuff. You can set this to 0, I prefer it, but it's really up to you. And now we are going to set the target group ID to 1, and it's going to follow 2. and I apply this. Okay, so perfect. Now it's going to look something like this. Almost done. We just need one more trigger for our instant doubling to work. We are going to clone this follow trigger and move it a little bit farther so the trigger priority problem doesn't strike. And now we need 2 to go back to its original position. How are we going to do that? Well, it's simple. 2 is going to follow itself on the negative direction. So it basically jumps to 1 and then follows itself back to the negative direction, so it goes back like this. And if we check now, we can see that it works. Perfect. Let's see if our method really works, and this should write zeros into the binary string. I'm going to put up a text on the screen so you can see how it looks. Yep, looks good. Okay, let's check it in a binary to decimal converter. And 512 translates to, 512 translates to this. So our sequence currently looks like this in the binary string. We can change our way of writing by just adding another trigger that makes the distance move by an extra number. So let's move it by 1 extra, and I'm also going to make this add 1. So we have this. These are only 1s, so if we check here, we are going to have 1s in the sequence. Perfect. Second thing is reading through the sequence itself. What do we need for reading? We need a mechanism that checks if our distance is odd or even. This basically means that the decimal number we convert this binary string into is odd or even. Why exactly? Well, if the binary string has a 1 at the end, the decimal number will be odd, so this is really handy. And if the 0, the decimal number will be even, so this is exactly why we need this checker. Alright, now we move on to the number checker. What is it going to do? Well, it's going to check if the distance between 0 and this collision block is even or odd, which will come in very handy because that's how we can look through the bit string. So first off is going to be applying groups. So I'm going to apply group 1 to this, group 2 to this, and to this I'm going to apply group 3. The way this will work is, first let's place down a touch trigger which activates group 4. The way this is going to work is this is going to be moving in this direction and these two are going to be moving in the negative direction. So they're going to close in on each other basically. Now just place down 3 with triggers, which is going to move these blocks. So 3 gets moved on the positive axis, which is basically 3 if you forgot. Apply 4 to this. 2 is going to move on the opposite direction, so wheel 1. Now, if you look at this, it works. So to be able to see which number is which, we will use a collision trigger, and basically each time this collides with 1, the number is going to be even, and each time this collides with 2, the number is going to be odd. So we are going to make this target, what's the next free ID? 5, and this target 6. We are also going to make them activate. So now I'll put down a pulse trigger, which is going to be spawn triggered, and the background is going to pulse with the red color if our number is even. So 5 is going to pulse if the number is even, and it's going to pulse in a dark blue color if the number is odd. So this should work. Let's check, for example, let's say 6. This is the distance from 1, 2, 3, 4, 5, 6. Okay. Now let's check. This has to be even. Yep. You can see this is an even number. Now let's check 5. It's going to be odd. Yep. So this is all you need to know. Now there are some things you have to know about reading before becoming a professional at using it. That is, when reading through the sequence, the bits at the end get deleted. Why exactly? When checking if the distance is odd or even, the distance gets divided by 2 on collision. So in the video I showed you, the example of the odd-even number checker, you saw that the distance just got tinier and tinier as the collision blocks approached each other. So since our distance is equal to the sequence changes with the distance. Meaning, if we scanned an even number as the decimal, the last element in the sequence or bit would get removed. And when we scan an odd number, you would expect that the result would be a fractional number, but in this case, it gets rounded down in collision. Okay, we reached a very important thing that needs to be included in sequence encoding, which is called mode switching. This is an important thing because we have to do multiple things in our sequence encoder. For example, we have to make a mode where it writes certain bits and then we have to read those bits, so it requires multiple modes. Now, for a simple example, I'm going to use where 1 will go towards 2 in mode 0, and when we hit 2 it's going to switch to mode 1, which makes it so it goes backwards towards this collision block, and then if it collides then it switches back to mode 0 again, and this is going to be an infinitely repeating cycle. So assign a group ID to this. I'm going to assign 1. Now put down a touch trigger and make it activate a free group. Perfect. Now we need instant count triggers for this. They're going to check the mode value. I put this here so it's easier to see. So we're going to check item ID 0 and check if the target count is 0. So while we are in mode 0, we're going to make 1 move towards 2. Pretty simple, right? So we are going to activate this move trigger if we are in mode 0. 1 will move towards 2. Very well, let's test it. You can see it works perfectly. It goes past because we haven't made condition where we need to switch modes. Mode switching will happen on collision, so we have to put down a collision trigger here, which is going to activate group ID 5, I think. Or was it 4? Okay, it was 4. So it's going to activate group ID 4 when 1 hits 2. And this is going to increase our mode. So we are going to increase it on collision. And if you look at it now, we switched to mode 1 and our collision block stopped moving. No matter how many times I click, it won't move. That's because we have to make another mode which checks for mode 1. So whenever mode 1 is true, or whenever we are in mode 1, we are going to make 1 move backwards, like this. So it's checking mode 1. If we are in mode 1, make 1 move backwards. Very simple stuff. And then we have to make the condition that whenever we meet 0, then we also switch back to mode 0. So we can have this infinitely repeating cycle, basically. Let's make that quickly now. This is going to trigger 6, and 6 is going to go back to mode 0. Alright, assign the correct group, and let's see. Okay, that's good. Now let's click. Wow, it works. This is how mode switching works. Different functionality in different modes. Very cool. So, I think that's going to do it for the first part. Thanks for watching. Have a good one.